And welcome, guys. Today we're going to be talking about quantum numbers. Now, this topic may sound confusing and hard, but it is really simple and easy to follow through if you can just see it in front of you. Now, we have our four quantum numbers. They're labeled as N, L, ML, and MS. They're used to describe a single electron in an atom, and no two electrons in an atom can have the same four quantum numbers. Now, starting off with our first one, we have our principal quantum number. Now, this tells us the energy level and distance from nucleus. This can range from 1 to infinity. Each number has a different shell, and the higher you get, the more energy it has. Now, moving on, we have our angular momentum quantum number. This tells us the shape, and this can range from 0 to n minus 1. So if n equals 2, L can be 0 or 1. Now keep in mind that when I say it ranges from 0 to n minus 1, it can be 0 or 1 and not 0 and 1. Now, another thing with the shape is it tells us our orbitals of s, p, d, and f, which we'll go over in a later video. Now, moving on, we have our magnetic quantum number. This tells us our orientation in a 3D space, and it ranges from negative L to L. And again, it ranges from, it is not all of them. So if L equals 3, ML can be negative 3 to 3. If L equals 1, ML can be negative 1 to 1. And if L equals 7, ML can be negative 7 to 7. Now our last one, we have our spin quantum number. Now this one just tells us our spin. We can either have a downspin or an upspin. Negative 1/2 is our downspin, and 1/2 is our upspin. And two electrons in the same orbital must hold opposite spins. Now let's go over a practice problem. If our principal quantum number equals 3, then our angular momentum quantum number must be 0, 1, or 2. And ML, our magnetic quantum number, must be negative 2 to 2. And lastly, our spin quantum number can either be negative 1/2 or 1/2. Now let's try one a little bit harder. I'm going to show 4 possible outcomes, and we're going to pick the one that cannot be. So you want to go ahead and pause the video and figure it out. And the correct answer is actually D, because our principal quantum number is 2, and our angular momentum quantum number is also 2. And as if you can remember earlier in the video, our angular momentum quantum number can range from 0 to n minus 1. So for this to work, it would have to equal 0 or 1. And thank you guys for watching. This was Quantum Numbers.